All right. Good afternoon, everyone. Welcome to the breakout session on protecting your workload with Google Cloud Next Generation Firewall. First, let me see a show of hands. How many of you identify yourself as a security practitioner? Network security. Somebody keep worrying about security all the time. Very good. All right. So I'm sure you're all struggling with the challenge of keeping up a very high security standard for all the dynamic workload that your team keep putting into the cloud environment. After today's session, I hope you will find the Google Cloud Next Generation Firewall will be one of the best tools you have in your hand to get your job done in a simple, scalable, and highly effective way. My name is Tracy Jiang. I'm the product manager for the Google Cloud Next Generation Firewall product. Today, I will be delivering the session together with my colleague, Osvaldo, from the network specialist team, and our customer, Josh, from Walmart. In the next 45 minutes, we have a pretty packed agenda. I'll kick off the session with a quick introduction about the Cloud Next Generation Firewall product with an exciting release announcement. Then Josh is going to come share his experience as a customer in using the product to achieve their cloud security goals. Then Oz is going to come share with you some additional technical insight on how to make the best use of the product to enforce your security posture, and end with a demo on threat detection and response. Now first, Cloud NGFW overview. When our customers come to the cloud, security is always on top of their mind. They often treat it as a great opportunity to get a fresh start where they can build a network with simple architecture and robust security posture, a network that's simple and safe to operate. As they expand the cloud deployment and bring in more and more business-critical applications, sensitive customer data, they always wanted to strengthen their security control without increasing the complexity of the network. Well, Google Cloud Next Generation Firewall, Cloud NGFW, is our answer to those requests. Cloud NGFW comes with 3 tiers with increasing functionalities. And today, we are very excited to announce the general availability of the highest tier, Cloud NGFW Enterprise, that brings together the power of Google Cloud's fully distributed firewall architecture together with the advanced threat prevention capability coming from Palo. Together, we hope to help each and every one of our customers to easily achieve a zero-trust network security posture in your dynamic cloud environment. In order to bring safe and simple, reliable firewall protection to each of the dynamic cloud workload, we took a very different architectural approach than traditional approach. The Cloud NGFW is built as a fully distributed firewall service that we built directly into our software-defined network with a virtual firewall engine following every workload throughout its entire lifecycle. As we expand the functionality from basic layer 3, layer 4 protection to layer 7 capabilities, such as IPS, TLC inspection, we did not move away from that architecture. Instead, we invented a protocol called Packet Intercept to logically expand those virtual firewall engines to include those advanced functionalities through a policy-based, transparent traffic redirection to a group of firewall endpoints that are fully managed and auto-scales. Under this architecture, turning on any Cloud NGFW functionality becomes extremely easy. Our customers just need to finish a one-time setup of those firewall endpoints, register their VPC to receive the service from those endpoints. Then after that, all they need to do is to configure firewall rules to protect any workload that they bring into the VPC without making any routing, IP, or network design changes. These distributed firewall engine also automatically scales with the growth of your workload and increase of your traffic volume, and the inspection is done close to the workload to increase the security and minimize the latency. With the increased threat of a cyber attack, our customers always want the best threat prevention engine to protect them 24/7. And that is why we partner with Palo Alto Networks to bring their advanced threat prevention engine into our distributed firewall system. This engine is backed by the massive deployment base, global visibility, expert knowledge on the threat landscape, and advanced AI ML analysis. Through this partnership, we're able to bring the most powerful threat prevention engine through the cloud native service and down to every network interface in Google Cloud. And all our customers need to do is to configure a rule to turn it on. Well, how do you best configure your firewall rule to protect all the different type of workload that you bring into our cloud? And that is where the IAM governed tag comes into play. In Google, you can associate an IAM governed tag down to every network interface level and use it as a very effective micro-segmentation mechanism to identify the type of traffic that you have in our cloud. Cloud NGFW integrated this IAM governed tag and allow our customer to write tag-based rule to express their security intent for each type of workload they run in the cloud. Using the tag-based rule, user can not only control the basic access control between the two different workloads, but also enable advanced functionalities such as IPS between any two directly connected network interface, even when those two interfaces are in the same subnet. Tag-based rule can also be used as a very effective threat response action. User can pre-program those threat response actions using the tag-based rules. Then when bad things happens, all they need to do is put a special tag on the infected system and immediately lock down the instance to prevent any lateral threat movement. Even better, later on, Oz is going to show you through his demo on how you can do it through a fully automated fashion to save you time and minimize damage when you are under attack. Using the distributed firewall architecture, we decoupled the firewall enforcement from routing. And we put a firewall engine close to workload to protect it all the time and inspect 100% of the traffic coming in and out of each workload. On top of it, we implemented a hierarchical firewall policy deployment model. There we allow users to associate firewall policy not only at the VPC level, but also at organization and folder level. As soon as the policy is associated, all the rules you configured in the policy were automatically deployed into all the workload that you deployed in the scope. And when a new workload is added in the scope, the system will automatically detect it and immediately push down the rule to protect it. Well, finally, we understand no matter how powerful the firewall engine is, you still need a very robust firewall rules to protect your workload. That is why we introduced a set of ML-based recommendations through the Firewall Insights module to help our customer constantly optimize their rule configuration and maintain a very robust security posture. No matter how proud we are in bringing this new product to protect your cloud, we understand the network security is never a one-size-fits-all story, and you may still have functionalities that's not readily available through our first-party products. Therefore, we are building a third-party extension module for the Cloud NGFW product, so you can bring the vendor of your choice and run it as a third-party self-managed endpoint under the Cloud NGFW architecture. The third-party extension module is going to support both inline interception mode and an out-of-band mirroring mode. User can configure native firewall rules to select the traffic to be intercepted or to be mirrored to a third-party endpoint of your choice. This module is still under development. It will be available at a later time. With this, I would like to invite Josh onto the stage to share his journey as a customer of using the product to protect their cloud environment. Josh.
Thanks for having me, Tracy. My name is Josh Cox, and I work for Walmart as the Group Director, as Group Director of Cloud Security. I get to lead a cloud security organization with teams of amazing engineers who secure configurations, enable and operate cloud-native security services, and help solve problems that enable our company to fulfill our mission, the mission to save people money so they can live better. Now you know who I am, who I work for, and our purpose, but what do you know about Walmart? We'll do a little audience engagement. Who here has shopped at Walmart, whether in-store, in our app, or online? Okay, we've got a lot of people there. Maybe we'll switch to one you don't know as much. How about Sam's Club, Flipkart, PhonePay, Superama, or Massmart? There are a lot more brands that are Walmart. Let me share some facts to help set the tone for the scale and the complexity of our organization. Walmart operates over 10,500 stores around the world, including e-commerce properties in 19 different countries. We employ over 2.1 million associates, 1.6 million of those in the United States itself. We serve over 230 million customers every week who shop with us and make it the place that they choose to spend their money. And we're striving to be the world's most trusted retailer who continues to earn the business of our customers and members. We're a people-led, tech-powered company who uses the latest and greatest technology to power experiences like Scan and Go, so customers can skip the line when they're checking out and do this on their phone. We offer generative AI search to help customers pick the best basket of items whenever they're shopping with us. Or others like Walmart Luminate, more focused on suppliers and buyers collaborating with big data. It sounds big. It sounds complex. It sounds ambitious. So why are we here? It's the need, of course. We needed to build environments to host the applications and the services that deliver on the customer and associate experiences that we need. We're here to lead the next retail disruption, and we can't lead without a place to host. Our solutions need to comply with every policy, standard, industry regulation under the sun, or at least that's what it feels like. What works in country A may not be acceptable in country B. What is not regulated today will probably be regulated tomorrow. Controls and capabilities that haven't been invented yet will likely be invented in the future. And we like to take an active role in the development of things that we need next. The environments that we'll describe here are considered elevated security environments. These environments have capabilities that need to be configured, and those that are not configured will need to have compensating controls introduced so that we protect the workloads. We have capabilities like Layer 4 and Layer 7 firewall policies, IDS and IPS, full admin audit activity logging, flow logging, packet capture, TLS inspection, firewall assurance auditing, and micro-segmentation for Kubernetes-based workloads. Today's presentation will focus on firewall segmentation gateway pattern for services running in shared VPCs that span multiple VPC service control perimeters with hybrid connections back to our private data centers and our edge sites like stores, clubs, distribution centers, and fulfillment centers. The next few slides are going to walk through our journey and experiences designing, building, implementing, and improving upon our designs. The diagrams you see are generalized and simplified to be easier to speak to. If you see something that looks too complex, that really does mean that it's too complex. We needed to build these elevated security environments to support those policies and rules and threat protections I previously mentioned. The environments in the different VPCs have specific purposes in their perimeters, and our intent was always to build a cloud-native solution using the best that GCP had to offer. On the left, you see the solution from 2022. GCP at that point had no Cloud NGFW. We had VPC firewall rules. VPC firewall rules didn't support fully qualified domain names, and they would require things like changes to established processes internally for firewall rule requests from developers. It did have the ability to full admin logging, rule hit logging, and the Network Intelligence Center has Firewall Insights feature that provided firewall assurance features to help us report on and to remove unused and duplicate rules in our environments. Well, that sounds pretty good. There were too many gaps compared to the capabilities that are expected in our company, so we had to do something else. In 2023, we revised this design to include the cloud firewall with VPC firewall rules, but introduced Network Virtual Appliance NGFW, something we're probably more familiar with as a group. The NVAs sit between the VPCs, and we also had to have additional tools to manage the NVAs to do firewall assurance functionality for the NVAs and report on them. The good news was GCP's networking technologies and security technologies are configurable and extensible enough that we could add compensating controls ourselves. The bad news is this big mess of green and red lines you see swirling around a network virtual appliance in the middle. It added a complex, multi-NIC solution that required firewalls to act as routers, and there was further policy duplication. Instead of only on the VPCs, also on the network virtual appliance NGFWs. The solution did, however, deliver on all of the capabilities you see. Now, this solution was not everyday low cost. So we followed Sam Walton's rules of building better businesses. One of those rules is to communicate everything you possibly can with your partners. And once your partners understand your business and they understand the outcomes that you want, they can do some really powerful things. So through this time, we're constantly communicating with Google, the customer engineers on our account, the product teams, sharing what we wanted the ideal product to be. And Google delivered feature after feature after feature to the point where we're starting to ask, do we really need network virtual appliances anymore? What were the experiential differences between our approach in 2023 and what Cloud NGFW can do now? We wanted simple, scalable, and performance service. If you operate production services in a growing environment, this should resonate with you. Let's compare these rows for simplicity, scaling, and performance to see what our challenges were and how Cloud NGFW offers some solutions. First, for simplicity. When using NVAs and VPC firewall rules, it required multiple teams and multiple tech stacks in order to manage policy. What that means when you're introducing change is things take longer and you're paying opportunity costs. Those also required logs and metrics to be stored in different systems. Again, duplicating efforts, spending extra money on additional tools. Third-party tools were also needed for firewall assurance. Network Intelligence Center Firewall Insights only applies to the Google Cloud Firewall, but not a network virtual appliance. And finally, if things were going wrong, we required multiple vendors for support to back up our security practitioners. Looking at Cloud NGFW, the policy becomes something you can manage with one team and with one tech stack. The logs and the metrics you need for observability are stored in services natively, or they can integrate with GCP's security platforms like Security Command Center and Chronicle. The Network Intelligence Center Firewall Insights feature provides all of the firewall assurance features so we can write better rules and remove duplication from the environment. And finally, GCP can provide all of the support that you need through the same support interface you would use for any other GCP project. For scaling, when using network virtual appliances, there's a disruptive redeploy operation that's required every single time you need to add network interfaces. So what does that mean? As your environment's growing, you need to create outages. Everyone loves outages from security, right? Okay. The post-deployment license management of network virtual appliances we used also meant that we had tasks rather than just deploying an instance where you'd need to do custom health checks to make sure licenses were applied and policies had been distributed before allowing traffic to flow through them. So pretty complex to scale. Looking at Cloud NGFW, it's a distributed, fully managed service. On the performance side, network virtual appliances introduce virtual machine networking limits, right? A VM size will determine how fast you can go and how many interfaces that you have. Using NVAs, we also created further duplication of policy rather than just on VPC level for resource level policy processing and a bump in the wire for network that would add latency to workloads, especially during high network throughput times, the times when you need it to be fastest. With Cloud NGFW, the service is part of the software-defined network. There are no virtual machine limits that are introduced. You get the SDN limits at this point. There's service capability insertion, so rather than breaking a configuration, applying new policies, deploying new firewalls, we can simply start annotating information about what this instance has on a tag or other basis to say inherit the policy. Hierarchical policies remove the rule and policy duplication so that we can write a policy once and rely on inheritance to apply that policy to all of the firewall endpoints in our environment. So why have a third design if cloud firewall with VPC firewall rules and network virtual appliance NGFWs work? Well, not only is Cloud NGFW simpler, easier to scale, and better performance, but it's cloud native, one of our original design intents. All of the capabilities are present that we required with a significant reduction in components, licensing, and network engineering knowledge required to operate it. So let's walk through the diagram. On the top left, one of the things you see is a change where there's a hierarchical policy rather than the VPC level. The hierarchical policy attaches to, in our case, folders in an organization hierarchy where the folders contain projects that are hosting shared VPCs. We can write once, let the inheritance take effect. And the good news when you move to hierarchical policy is you begin getting support for the layer 7 features. One we needed was FQDN for target destination. That's something that drove us to use in VAs before, so we could get that feature. You can see that the exact same VPCs are on this diagram that were on the previous two as well. However, now, instead of just allow and deny on the red or the green lines between the VPCs, there's a new component introduced that's packet intercept. The packet intercept component can send traffic to the Cloud NGFW IPS, the intrusion prevention service, for further inspection and prevention if needed on zonal endpoints of the VPCs. Note that only Trust VPC in has all of the IPS inspection occurring, and that's because there's a threat protection policy associated with that VPC, but the rest of the VPCs don't have threat protection associated. On NVA, this would usually be something you'd have a separate set of interfaces for. With Cloud NGFW, it's simply a threat protection enabled in a policy. We still get all of the policy in the Firewall Insights feature under Network Intelligence Center in the bottom of the screen, but no longer require a third-party firewall assurance platform to do that for an NVA. The biggest difference in the diagram is what's missing in the middle. There are no more NVA NGFWs. There are no more managing limits, licenses, routing, or dealing with disruptive scaling qualities of network virtual appliances. We're able to focus on the intent of what we're trying to achieve more than operations of a complex environment. We've talked about a 3-year journey to get to where we are today. We communicated constantly with our Google partners the entire time and can see the results. This is a quick recap of where we started and where we are now. So point 1, this was a production rollout of the 2023 design with network virtual appliances, VPC firewall rules, and firewall insights. We continue to progress as the features are developed and migrated in point 2 from use of VPC rules to VPC scoped hierarchical policy, reducing a lot of the duplication that we saw before. In point 3, fully qualified domain name support was added to policy, introducing those layer 7 features. And we also began to get our packet capture capability through ILB packet mirroring, sending to our own collectors. And Cloud IDS was added for that to begin doing intrusion detection. In point 4, we got what we really wanted, was IPS in the Cloud NGFW platform and TLS inspection and decryption. This is the point where we believe all the capabilities were feature complete. We conducted technical POCs to make sure that your security practitioners, you trust but you verify. So we did that at that point, and we're able to say, yes, indeed, the features that we needed are present. Now at point 5 is where we are today. We're progressing through functional proofs of concept to make sure we're not going to break applications or services as we roll things out, and planning our non-disruptive migration so that we're not the security team who, as we introduce new things, we break things, but we do it in a transparent service insertion model as the workloads migrate. While I get back to planning our non-disruptive migration, I'd like to invite Oz to the stage to show how that kind of migration can be done.
Thanks, Josh. All right, so okay, so with that, let's have a look into the strategies that we can take to make that migration happen in a non-disruptive way. So the very first thing that I want to cover here, even before we talk about NGFW Enterprise and Layer 7 inspection, is there are still customers and deployments that are using VPC firewall rules. So the very first step that needs to be taken is to migrate those scenarios to network firewall policy. So we have developed a migration tool that can aid in that. So the first thing that we need to do in that case is to identify those workloads that have network tag bindings. Once we identify that, we can create a map of the secure tags and create the correspondent network tag. Then we can use the tool again, if desired, to do a bulk binding. So bind all those VMs that had network tags with the new secure tags. The next step is then use the tool to analyze the firewall rules and generate a network firewall policy. That network firewall policy is not going to be applied to your VPC automatically. So you'll have the chance to review it, make sure you're happy with that, and then associate with the VPC. By the way, one of the possibilities here is you can swap the enforcement sequence if needed. So you can decide if VPC firewall rules or network firewall policy, which one applies first. So once you apply that, we typically recommend take advantage of firewall rules logging and firewall insights so you can make sure that the rules are being applied as desired, verify for shadowed rules, and then once happy with the results, you can disable or delete your VPC firewall rules. All right, so we look now, our deployment is now using network firewall policy, and we have unlocked the new capabilities. So let's take a look now into how we can enhance first, before migrating, an environment with a route-based NVA that is inserted, which is shown here on the left side. So on the left side, we have the typical scenario with an NVA in between a hub and spoke using peering, right? So we can improve this topology here by adding Cloud NGFW Enterprise in a non-disruptive way, and also adding functionality, which is the intra-VPC/subnet inspection on the spokes VPC, which is not something that is doable today in an easy way. Now we are going to have a look into the detailed architecture. So this would be kind of a simplified example of Josh's spaghetti architecture on the left side, but we are going to look at the step-by-step flow here. So we start with the north-south flows, again on the left side here for the NVA. So the very first thing is the workload. We use static route in that spoke VPC that can be exported or created manually. That static route will force the traffic through the NVAs. Those NVAs will have to source net the traffic, assuming the typical topology with an active-active deployment without session sync. That's for the outbound traffic. If you have inbound traffic and you're exposing your NVAs, they have to become the backends of an external load balancer, and then you'll have to source net and denet that traffic again to make sure that you have symmetry. How can we simplify that? So with Cloud NGFW, let's take the same environment, but focus on our internal VPCs now. The first step is create the zonal endpoints. So by doing that, you create the zonal endpoints where you have workloads. The next step is you associate those endpoints with the VPCs that you have, and then you update those firewall rules, now having the action inspect. That's all you do. At this point, if you still have your NVA inserted, you might have double inspection. However, only traffic that is allowed will flow to your NVA, so you are not blocking any type of valid traffic. Plus, you can also set the action or the threat profile that we are going to see in a minute to not block and just alert. We are going to create CloudNet in the VPCs that require outbound access, so you can still maintain your internet access. And we are going to update our external load balancer backend to now target the web servers or your service instead of the NVAs. And last but not least, if you need east-west traffic, we are going to set up some inter-VPC connectivity, in this case here, VPC peering as an example, and allow traffic to flow. If we look into how east-west looks like with the same topologies, on the left side, it's very similar, right, to the outbound. The difference is, in this case, the traffic does not need to source net it because the internal load balancers, the Google internal load balancers, we support symmetric hashing. Now, with NGFW Enterprise, we can enhance that security posture, enable inter and intra-VPC subnet inspection based on the rules that you create. And I want to highlight here one thing, which is you can use resource manager tags which also are supported across VPC peering. So you can create those rules and go beyond the 5-tuple, the IP port protocol rule, and really apply microsegmentation across VPC peerings and enable the layer 7 inspection based on your criteria. That's great, but now we have a ton of telemetry data, right? So we have firewall logs, we have threat logs for every security event. So what do we do with all of that, right? We love parsing logs one by one. So what we can do here is, in our demo, we'll see how Chronicle can be used to detect, investigate, and take action on potential attacks here. So in terms of the flow here, we'll have our 2 instances here generating some attacks. Those instances, that traffic will be intercepted, and logs will be generated for the relevant events and will be populated into cloud logging. Chronicle can support native ingestion from those logs in real time. So Chronicle will detect that. Using the built-in parser, it's going to map those fields to Chronicle's unified data model. And then we can create rule-based rules that will raise alerts and generate cases. Based on those cases, we can take action and mitigate our attack if that's the action that we need. So now let's take a look at the demo. So the very first thing here is we have our 2 instances in this case. They are configured. We have resource manager tags. In this case, just a client tag in the client. And if we click on the NIC, we can go ahead and select the firewall policy and review it. So we have a basic, a very first rule here with a predefined quarantine tag, and that's what we are going to use to take action. So once we apply, when you see the SOAR action that we are going to use on Chronicle, once we apply that tag to the workload, all traffic will be blocked. Next, we have some other predefined rules in terms of allowing well-known ranges, blocking embargoed countries, blocking threat intel that we know, and also applying FQDN. And we have the 2 last rules. They are inspecting traffic using secure tags and address groups, so you can simplify your management. And if you scroll here to the right, you're going to see that we enabled logging and enabled layer 7 inspection on only those rules, and logging only for the traffic that is relevant for us. In this case here, just for demo purposes, I am logging all incoming blocked traffic, so we can take a look at what's showing up, and also the layer 7 threats. Now we are going to check here that our firewall endpoint is active and associated. And let's have a look at the rule that is inspecting, because it's linked to a threat profile group that has our relevant config at the threat and severity level. In this case, we are using the defaults, but note that you can override. So you can set it to alert instead of taking the default action. Okay. So now we are going back to the threat dashboard, make sure there are no threats, And we're going to our client, verify first basic connectivity, so I can reach my web server, and then send some sample attacks. Some of those attacks, they will time out because of the predefined rules. So we are going to go back now, look at the threat dashboard, and see the logs that were captured and generated. So sometimes it takes a few seconds, so make sure you refresh here. And in a second, we should see the logs being populated, the different logs that I'm sending with the different severities. So we can see here the different severities, high, medium, low, and the corresponding action that was taken based on that config. All of this is generating a log entry that is being ingested automatically by Chronicle. So let's have a look at what Chronicle is seeing. So Chronicle now, I have created a threat dashboard, a custom threat dashboard that you can also create based on the criteria that you want. So in this case here, the top ones, the blue ones that I created are based on the threat logs. So the top 10 threat severities, top 10 attacks, and top 10 attackers, so which are my east-west. And the red ones here are the rules from the login that I'm blocking all incoming traffic, so we can populate and enrich a little bit. So the reason why, by the way, we are seeing all this data here is because I decided to enrich those IPs, and we're going to take a look in a minute into how that's done. Now, as a security analyst, we look at the dashboards, but we typically start from a case, not from a log. So we are going to have a look now at how a case looks like, which is the aggregated alerts that I generated. So first one is looking at alerts from denied IPs. So we have an AI investigation that is going to look into that case, summarize for me, and give suggestions on what are the next steps that I could take. But we can go deeper and click on Explore and see actually the map, the number of IPs that were detected. They're trying to reach my IP here. And we can go even deeper in looking at that IP, looking at additional information that was enriched. And here, going even beyond, we have the VirusTotal, information from VirusTotal, providing additional context. And noticing that actually this IP has been flagged as malicious by 12 security vendors. So we know that this can be an interesting thing. So we can go back here, take a look at the alert, and see the events, the individual logs that were detected and raised that case. And we can also see here the playbooks, which define the action. In this case, the action that I have defined that happens automatically is enrich those IPs, so I know where it's coming from. So that's how we get more information about the IP and not just the source. Now we are going to review here the threat logs, which are the layer 7, as a result of the layer 7 inspection. So we also have the AI investigation here, summarizing the attacks that we're seeing, the source, which is my client, and a suggestion of what we should do. But let's go ahead and look straight into one of the events here. So we can click on those events, on one of those events, we can view more, and we can investigate all those parsed fields that were mapped. So we can see the severity, we can see the threat name, we can see the action that was taken. And we can see it's an Apache Log4j, so it's something that maybe we should investigate who's generating that. So we are now going back, and let's do an additional research. Well, first let's have a look at the playbook, and we're adding a tag here so my analyst knows that we should flag this. We should look into this because it's a high severity one. Now let's look at that IP here, and we can see that that IP is generating more stuff. So let's do a query on that IP, and we are going to use Chronicle's UDM, so I don't need to guess what fields I could use. So I can just filter. I'm going to select here, the timestamp that I want. And we are going to now filter here and add a criteria. So here, I just want to highlight that all these fields that you're seeing here, they are being populated automatically by the built-in parser. So as soon as you start feeding Chronicle with the threat logs, that mapping will happen. There's nothing that you need to do on your end. So as such, you can just add the field that you want, in this case, the log type, plus the IP. And we are going to see that as a result, there are many attacks that were generated by that VM. For demo purposes here, what we are going to do is take advantage of Chronicle SOAR to take an action and add a tag to that VM, the tag that we referenced, and now block all traffic. But if that's your company policy, you could instead mirror the traffic and take another action. Just a note, this here can be customized. So it's a custom action. You can develop your own code and do whatever you want, basically. So this here can integrate with Google Cloud Console. So my custom action, which is add a secure tag to my VM and the tag that I had predefined. I will execute, we'll make an API call, and run that. So completed, all good. Let's go back and check the VM. So first, check the VM, make sure that the tag was applied successfully. It's there, the quarantine tag. And now let's try to access again, which should fail because the traffic is now blocked. So with this, you can have a complete feedback loop, right? We run through detection, through detecting the attack, investigating the alert, and taking an action to block all traffic, mirror all traffic, and customizing the action that you want to take. So we just learned how Cloud NGFW can simplify and improve your network security deployments while delivering scalability and performance. And together with Chronicle, we just realized that it can provide a way to detect, analyze, and respond quickly to security events. So we hope that you are as excited as we are with these new launches, new integrations, and we invite you to work together with us and start your own journey. So feel free to come talk to us. We'll be around. And if there are any questions, I believe we have a few minutes yet, so we can answer questions if there are any.